Imagine waking up one morning and discovering that almost everyone your species ever knew was gone. Not a few people, not a bad year, almost everyone. Somewhere deep in our past, our ancestors may have come frighteningly close to that. Close enough that the future of everything we'd become, cities, languages, this very video, hung on the survival of a tiny, struggling population. So here's the question that should keep you up tonight. How did humanity survive when there were almost none of us left? Let's start with the number, because it's the kind of number that stops you cold. Some geneticists estimate that our ancestors were once down to around 1,280 breeding individuals.
Before you picture 1,280 lonely people wandering an empty planet, let's slow down. Breeding individuals is a genetics term. It means the number of people whose genes actually made it into future generations, not a literal head count. The real walking around population may have been somewhat larger, but even generously estimated, we're still talking about a population small enough to fit in a single office building. Small enough that losing a handful of people in a bad season could have mattered enormously. And scientists believe this tiny population held on for around 117,000 years. Let that sink in. We'll come back to it. To understand this story, we have to go back roughly 900,000 years. Homo sapiens didn't exist yet. We're talking about ancient human relatives, somewhere further back on the long, branching tree that eventually led to us. A different world, a different climate, and something back then nearly ended the story before it began. So what went wrong?
Honestly, we don't fully know. There's no single smoking gun, but there's a clue in the timing. This bottleneck lines up with a period geologists call the early to middle Pleistocene transition, when Earth's ice age cycles fundamentally changed rhythm, stretching from roughly every 41,000 years to closer to every 100,000 years, with far more extreme swings between warm and cold. For a small population, that kind of upheaval could shrink habitats, scatter food sources, and cut off groups from each other in shrinking pockets of livable land. When your world keeps changing under your feet, and your numbers are already low, survival stops being guaranteed. But here's where it gets strange. How do scientists even know this happened if no one was around to write it down? The answer is hiding in you.
Think of it like thousands of people walking across wet cement. Long after they're gone, the footprints remain. Our DNA works a bit like that. When a population crashes down to a small number of breeding individuals, most of its genetic variation gets lost, like a library losing most of its books in a fire, leaving only what a few survivors happen to be holding. That loss leaves a signature. By comparing DNA from people all over the world today, scientists can essentially run the tape backward and estimate when populations crashed and roughly how small they got. That's exactly how this bottleneck was uncovered, not from bones, but from patterns quietly written into the genomes of everyone alive right now. But here's the part that should really worry you. 117,000 years.
A population that small, staying that small for that long, faces compounding risks. There's the obvious one. A single harsh winter or disease outbreak could wipe out a meaningful chunk of a group with no larger population to fall back on. There's a quieter one, inbreeding, as the pool of potential partners shrinks and harmful mutations surface more easily. And there's the slow one, losing genetic diversity, which acts like a survival toolkit. Less diversity means less chance that some individuals carry traits that help the group cope with disease or a changing world. By every reasonable expectation, this population should have been fragile, breakable, erasable. So how did they make it through? We don't have a confirmed answer, but researchers point to a mix of possible factors. Cooperation. Groups that shared food and looked out for each other's offspring may have had a real edge. Mobility, following animals, seasons, and water instead of waiting for local resources to run out. Adaptability. New tool-making and food processing techniques may have opened up nutrition sources that weren't available before. And possibly occasional contact between separate small groups, avoiding the worst effects of total isolation.
Some of that is evidence. Some is educated reasoning. It's important to be honest about which is which. Now, here's a twist you've probably heard a different version of. You may know about Mount Toba, a massive volcanic eruption around 74,000 years ago. For years, the theory was that it triggered a volcanic winter, collapsing food chains and crashing the human population to just a few thousand survivors worldwide. Dramatic, cinematic.
But here's the surprise. More recent archaeological evidence has pushed back hard against that idea. Sites in Africa and India show continuous human habitation spanning the exact time of the eruption. No clear collapse, no dramatic break. The story turned out to be far messier and far less certain than the popular version suggests. And critically, Toba is a completely separate story from the 900,000-year-old bottleneck we've been building toward this whole time. Different event, different era, different mystery. Easy to blend together, but the science treats them as two distinct chapters. So let's bring this back to you, sitting here, right now.
If that ancient population, that impossibly small, impossibly stressed group of ancestors hadn't held on, none of this exists. No cities, no languages, no smartphones, no you watching this. Every person alive today is part of an unbroken chain that somehow survived one of the most dangerous chapters in our entire history. We don't know exactly how they did it. We just know they didn't disappear.
We don't know exactly
And
how
that's
they
the
did it.
quiet, strange
We just know
miracle
they didn't
sitting underneath
disappear.
every human life
And
on
that's the
Earth
quiet,
right now.
strange